Hey, it's Piotr
Derek?
today we'd like to show you our latest set of libraries that we named Convey. And
Yeah.
as you can see on this website, which is the docs for the Convey, um, it's not a framework, it's just a set of the help libraries for building .NET Core, microservices, and web APIs in general, right?
Yeah, maybe the short story before we actually move forward. If you know us, you probably recognize the distributed .NET Core. That was the video series created for YouTube,
Yeah.
about 20 long hours.
DevMentors.io, courses, .distributed.core, and
Yeah,
here are the
yeah,
YouTube videos, about 20 hours of free course.
yeah, 20 hours long, and back then we. Because basically, when we create microservices, we would love to have our infrastructure extended to and put somewhere outside, so we could share the same infrastructure within all our microservices. Right? We don't want to copy paste the configuration of the MongoDB or the RabbitMQ or whatever we want to use. We want to put this on a NuGet package and share this across all our microservices. And back then we had a repository called, I believe that was
this one.
Yeah, the DNC, yeah, DShop Common. Yeah.
Common.
So basically that was the whole infrastructure put into one huge NuGet package. So as you see, we had Fabio, we had console, Redis, RabbitMQ, a lot of stuff. And that worked well for us. The issue was that not all microservices always share the same infrastructure, right? Because maybe some use other data storage, or maybe they don't use asynchronous communication. So that was a pity that even though some of our microservices didn't needed a lot of stuff, they had to fetch this because we had just one huge package for the infrastructure. So the Convey was something like the next step. So we decided to chop this huge package and put this into separated small modular NuGet packages, and that's how the Convey was born actually. So of course there was a lot of refactoring involved in that process. And in the meantime we also migrated to the .NET Core 3.0. So there is this is it.
So previously we had our previous organization at GitHub Convey stack, and now we've migrated all of these separate repositories into the single repo, which is under, if you go to Convey stack GitHub.io and you click on the repository link, you will see that under the SnatchDev organization, here is the Convey, and also a few more libraries. For example, Chronicle for dealing with Saga pattern for .NET Core, Entrada being then API gateway, and so on, and also the Convey. And we'll stick to the Convey today, and we'll show you how you can use it, or some parts of it, to build your web apps much faster, I think.
Yeah, because it's worth mentioning that the Convey itself was meant to be dedicated especially for the microservices, because let's be honest, the microservices is pretty much more or less about the infrastructure. The business is not that complicated because the infrastructure is the part that actually people tend to struggle with. But of course, if you have monolith application, you can still use a lot of packages and avoid hours spent on your infrastructure, figuring out how to connect to some data storage or how you should maintain your health checks or whatsoever.
Yeah, and right before we jump to the code, one more thing. Here is the documentation, so you can read the docs here. Just keep in mind that we are upgrading the packages, and also we are upgrading the docs, so they might change during the time. But basically, you can find the docs for separate packages that are using Convey, and you can find what to do with those packages, how to configure them, and so on, on. All right. So now
just one more thing before we actually move forward. Please, that would be really cool if you could first, of course, give us a star on GitHub. That would mean for us that you actually like this. But if you'll find any issues with configuration, or maybe something is simply broken,
just click
don't
here.
hesitate to use the issues.
Or even better, here. Okay.
Yeah, give us an issue and fix it. That would be the best one. But just keep in mind that we do this, a part of our job. So yeah, we need some time to actually take care about this project and fix some issues.
Okay, so currently you can either grab the master branch and you can just clone it, but we'll be running this demo based on the demo branch. So if you like to try it on your own, you can just git checkout to the demo branch. And of course, all of these packages are available through the NuGet. So if you go to the NuGet org and you type convey.whatever, you can see that there are the packages. And currently we have either the 0.3.anything being the .NET Core App 3.0 integration, and we also have the previous packages without this 3 in between, which means it's for .NET Standard, .NET Core App 2.0. And let's get into the code. So if you open the code, I will switch back to Rider in a minute. But once you clone the repository, you can find here under the samples that there will be the sample app that we'll be using right now. And also, in order to start all of the required infrastructure, here is the compose folder. And under Lean OS 6 or Win, you can find the Docker Compose YAML files that you can start. So your infrastructure will be up and running for the demo purposes, of course. So let me jump here. And as I type Docker PS, right now there's nothing. I will just do build for the first time and then up -d. And now all of the required infrastructure for the demo is available. Okay, so I won't need this anymore. And also here I opened 3 tabs because you have 3 different, very small, and I would say naive microservices here for the demo purposes. These deliveries, orders, and the pricing service. So let me open the rider, and under samples, here are our demo apps. These 3 services, right?
Yeah, we skipped in this demo. We skipped the API gateway. We'll just talk to the microservices directly for simplicity purposes.
Yeah, we skip pretty much everything. I would say these are very very straightforward, very naive microservices. There is no layers, nothing whatsoever. If you're looking for like more very well written project, I would say either start with our course and go through DShop, or check out the Paco and these 10 microservices, which are built with some really nice clean architecture, different layers, nice abstractions, and so on. But for the demo purposes, for this 1 hour, this will be enough.
DShop was simplified when it came to the architecture of the particular microservices, because we decided to keep everything in just one project, while when in the Paco we had the different structure and the architecture, of course, for different microservices. So this is way cooler if you pay attention to the architecture per particular microservice.
Exactly. And before we begin, let me just do one thing. Since I'm running on Linux and I'm binding my Docker to localhost, I will just change these magic URLs to bind directly to localhost. We'll use it later. But if you're on Windows, you can just stick to this Docker for Win URLs. And if you are on OS 6, you should change this Win to Mac, and this will be just fine. But I'll just change it to localhost since I'm on Linux. And okay, so what our services do? So we have delivery service, orders, and pricing, right? And there's this very simple flow where we will send a post request called named create order. It will save an order to database, and then it will publish some event. Then the delivery will start, and will also fetch the price from the pricing service.
Yeah, pricing. Yeah, we'll use the pricing for getting the, as you see, very simple DTO, which has nothing more than order ID and some hard-coded total amount. So basically, while creating the order, we'll just create an HTTP request to this service.
Yeah.
We'll get this DTO and we'll save the total amount in our order.
Yeah. So let's start the services, and I will just start them through the console. Just .NET run, .NET run, .NET run 3 times. Sorry, .NET. So our first service is there, our order service should be up and running, and our pricing service as well. Okay. And we should be able to browse them under localhost 5001, 2, and 3. 3 different services, 3 different apps. And
so far, so good.
Yeah, so far, so good. And here, if I open the, for example, VS Code or any other IDE, you can find that under samples, there is this conveyor.res file. And this is the extension called REST client for VS Code, which we are using to actually define the file in which we can have these requests, just following the convention, 3 times hash, name of the HTTP method, URL, params, and that's it. So as you can see, I can do get, and I can also do this post. So this will be our flow. Post to the order service running under localhost 5002 with this content type and this request body, this simple JSON.
Yep.
And
for now, it's 404.
Should be API. Yeah, should be API. Like
and just keep in mind that if you don't want to use this REST client for some reasons, you can stick to other clients like the Postman or some Telerik clients for doing the HTTP requests. We just think that this is the fastest way because we can keep this, and we can also keep this in our repository, so we don't have to type the whole flow, store this somewhere else.
Yeah. All right, so far so good. So as you can see, post that does some post request and creates an order. Right now it does pretty much nothing, returning a location header, and we can also do this get. So let me open this URL, for example. As you can see, here I have my order DTO, right? Very simple stuff, nothing fancy. And let's switch the code. So we'll be working under the order service all the time. And so far, there's nothing really special. It's just plain ASP.NET Core app, where I'm saying add MVC core libraries, add newtons of JSON as serializer, and just configure routing and map the controllers. And again, typical stuff. So under the controllers directory, you can find the home controller returning our hello world message and the orders controller with 2 methods. One for get that will return the order DTO, and another one for post that will consume this request, and at some time it should create our order and save it into database.
Yeah.
All right, so let's do a little bit of the refactoring. We will start with the first thing, and also all of our projects have the references to the Convey packages. Since we are in the same repo and here are the Convey packages, we can just reference it as the file. But again, everything is on Nugget, so if you are building your own project and you don't want to copy or fork the code, you can just do package reference, include convey that whatever, and grab it from Nugget. So this is what you would do in a typical scenario. All right, so let me open the program CS, and let's do the first step.
With what? We're gonna start with the.
I think with the
pattern.
handlers.
Yeah, with the CQRS.
The CQRS.
So basically, you would like to introduce the CQRS. I would say the messages, so the commands, queries, and also later on we'll also introduce the events. And basically, you would like to have some definition for each type of message and the handler that will consume the message and process it.
Yeah,
one way or another.
So as you can see here, just like you said, we have the post message, and it takes and create order something. So if I go to the definition, you can see that under comments, we have this class create order with some parameters. Everything is immutable because we don't want our comments or events to be mutable. So they are immutable. Everything works fine with newtons of JSON order serializer. There's no problem with that. Here's the definition of the use case. So the user, let's say he wants to create an order, and that's it. And for this create order command, we have the handler, so something that is able to consume the message, right? So
one more thing, the iCommand interface comes from the
and it's just a marker
package.
It's nothing special.
And this is used just for the generic constraints. So Don't worry.
Exactly. And all right, so for each of our I command, we have the I command handler, which defines what the command should do. So if you are familiar maybe just with message command handlers pattern in general, or if you've ever used libraries like Mediator, it should be straightforward for you. So we have the command handler of this type T that has this single handle async method, and here is my use case, and here is my application logic, right? So this is where all of this magic should happen. So here I should, for example, inject some repository, save order to DB, send a notification, and so on and so on. All right. So right now we want to make it work. Okay. So let's get back.
So
here.
we need, at this point, we need two things, right? We need to register somehow these handlers, because we will use the dependency injection provided by ASP.NET Core, and we would need some other component for actually sending the commands from controller to the particular handler, right?
Exactly. So if you take a look at these command handlers, this is very simple. So we're just scanning our assembly, looking for the I command handler type, and the actual dispatcher as the command dispatcher. And in a simple scenario, the command dispatcher is a type that is able to send our commands. So again, it can be as simple as just a service locator doing this stuff internally. But it could also be like a message bus dispatcher or anything else, just an abstraction. So this is for the starters, okay? And as you can see, we will start everything with @convey, then our extensions, and then build, because we can also set up some build scenarios or some initializers and so on with this library. All right, so let's refactor our controller, and let me just inject I command dispatcher. Okay, and under my post, I want to do the following. I want to say command dispatcher send async command. Just like this. And maybe I will just put a breakpoint here and also here just to prove that it works. Let me stop the order service and let me run it in a debug mode.
Okay, so this should take the message, and dispatcher would be responsible for seeking through our registrations, finding the appropriate the command handler and invoking this, right?
Yeah. So here is my command. This is my input from the request, and F5, and I'm getting into my handler. Everything is done. Everything works fine. Okay, so that was it. Now let's do another thing. Let's say we actually want to store this data somewhere, right? So if we get into our create order handler, I would like to create a new order here. New order. The order takes 3 parameters, which is the order ID, which can be pre-generated or it can be generated by your database. It doesn't really matter. It takes the customer ID and also takes the amount. So for now, let's make an amount a fixed value. Let's say $100 or euros or whatever.
Yeah.
So here's the order. Now we want to save it into the database. And again, you can use any database that you want, whatever it is with SQL Server, Postgres, SQL, Redis, whatever, anything else. But for the simplicity purposes, we'll just add this integration with MongoDB here. So if we get back to our program CS, we can type @mongo, and we can also type @mongo repository. This is just an abstraction over iMongo database and MongoDB driver library, and we can say for our order class, which is defined here, and this is very simple. Both actually the domain model and the, let's say, application model. So as I said, no layers there at all. And here's the order, here's the type of its key, and the name of the collection should be orders. And one more thing, because within the Convey, we can also define the initializer. So if you have some startup action, you can either add this build action or you can add this initializer. So let's say you want to seed your database with the data, or you want to call some service before starting the app, and so on. So you can do it with these initializers. And in order to run the initializers, just type use initializers here. You can also yes.
Yeah, so this will run the all defined by the user, right? I mean the initializer defined by the user,
Yeah.
and also implicitly defined by us. So in this case, in case of MongoDB, we will run the initializer that would create some basic conventions for your database.
Yeah, for
Right?
example, yeah, we have like MongoDB initializer that creates some conventions for the MongoDB here.
Yeah.
And it will be run within this use initializers. All right, so here's our Mongo. And all of these settings are defined in apps.json. So here are the section names. Of course, you can change those section names. These are default names. For example, here is the Mongo, which is straightforward, connection string, database, and if you want to use the seeder, either true or false. So it should create a new order service database under the localhost. So if we go back to the controller and actually the handler, we can now inject, for example, the either iMongo database that comes directly from the library or iMongo repository, which is our additional abstraction. So for the order type, GUID, we have the repository.
Yeah, I would say that for the most operations typical for your application, the iMongo repository is fine because it provides the basic
Typical
operations
CRUD stuff.
like insert, upsert, delete, some filtering. So this is a way to go.
Okay, so let's start the app one more time. And now we should have our data stored to the database actually. So just to prove, here is the robo3t and I can connect to the localhost. Everything is running through the Docker. Now I don't have a database. Let me go back to the app and we can just send the post request again and we can refresh it. Sorry, this one. Refresh, and here is the order service and orders and our data.
Yeah,
it's here. Cool. All right, another thing. So just like we have our commands, we also have the queries. So here's the command, do something, right? I want to create an order. I want to send a message. And the query is just, I'm asking for data. So the same pattern, just a different meaning. And here we have this iQuery interface, which is again very simple, just a marker interface with this generic constraint of type T. And we are saying,
Can I mention one more thing? Because I think this is pretty important for people who will decide to use Convey. We decided to stick to the CQRS, which means that our command handlers will not return any data. So in this case, we have the command will mutate the state, but will not return any data. It will return the task, non-generic. So you need to consider this before you will actually start using the Convey, because this has some major implications in your system. So the queries do the exactly opposite thing. We return some data, but will not mutate the state, will not run any business logic here.
But we have also one more, I would say, generic thing, which is called iRequest handler. So this is something generic that you can use. So it will take the request type and the result type. And if you want to return the result from your comments, you can use this one. And for example, have a comment that saves an order and returns the order ID coming from your database. So you can also use this request handler and request dispatcher, and it's pretty much the same. So it's really up to you. All right. So here is the get order query. And for our query, you have the handler, get order handler. So what it does. So it takes the repository, or it takes the pure SQL connection, or maybe it takes the caching, or anything else. Because if you are doing CQRS, keep in mind that you can actually split your domain model to have your domain model and your read model, like two separate models. And one can be saved in your primary database, and the read model can be stored in your cache in a different format, right? So you can do it here with this pattern.
It can be also optimized for readings, right? So you don't need to have one database for this for your whole system. You can have some part optimized for readings, let's say the normalized database in SQL.
So in our scenario, in our demo, we are using the same repository, but the data, the ZTO could be coming from cache. So just typical stuff. grab the data from somewhere,
Yeah.
transform it, and return it, right? And let's change the, at first let's go back to the program and add one more thing, which is called query handlers, and add query, and in query dispatcher, this one. And let's get back to our controller, and we can now inject the iQuery dispatcher. And here we can say order equals await query dispatcher query async this query. And based on this get order definition, it will find out that we are asking for order DTO as defined here. And this is the order DTO returned here.
Yeah.
And of course, if it doesn't exist, so let's say if order is null, let's return not found. So 404, and let's give it a try. So restart one more time. And let's do a post. Okay, let's open it. And it's fine, everything is coming from our database, right? So just as we expected. Okay, another thing. And this is gonna be actually, I think, more
interesting
stuff than this. So what about getting rid of controllers at all? I mean, you can use controllers, but keep in mind that controllers is just additional middleware, and it's something that has to be, handled by the framework, and sometimes it costs you some additional memory or performance per second and so on. So we can get rid of this stuff at all. I mean, it can coexist, but we can get rid of it. So maybe just remove everything, I think.
Yeah, it can coexist, but we'll just remove it.
It can coexist, but we'll just remove it.
Yeah, so to prove that this actually works.
Yeah. So let's remove this part as well. And also let's remove this part as well. And let me add the Web API integration. So Web API under the hood uses the MVC core and some additional stuff. It also uses the UTF-8 JSON format serializer, so it's much faster than Newtonsoft, and also the latest .NET Core 3.0 JSON serializer. And what we can do about it? Well, we can say use endpoints. And the funny thing is that when we build it in 2.0, there wasn't a method called use endpoints, but in .NET Core 3.0, the MS added the same method with the same name.
So basically the Microsoft is spying on us.
Exactly.
Yeah. So they added this functionality. We're first. We can prove this.
Yeah, we're first. We can prove
we'll
it by
sue you.
commits.
No, I'm kidding.
All right. So we have use endpoints coming from the actual framework, but we can also have use endpoints method coming from our Convey package. So here I can define that. For example, I want to have an endpoint for get. Let's say this is my base path, and here is my context, HP context, and my context should, let's say,
just return the string.
Just return our hello world. Let's say we have order service.
Yeah.
And let's maybe define another one with some routing in place. So let's say we have whatever, ping returning a pong. Okay. And let's see if it works. So restart again.
And it's also worth mentioning that you can use route or attributes or query string just like in MVC controllers. And this will be binded automatically to whatever you expect. So DTO or some command or whatever.
Yeah, exactly. Everything works.
Yeah,
and of course, our post doesn't work, not found, which is okay. And also our get order doesn't work yet. So let's get back to the code. And I can also make it a little bit prettier. Just remove this and this. Okay. And let's say we want to deal with our get order and create order. So what we can do? Well, at first, we could do get. Another get here.
You mean post?
Yeah, I mean whether it's get or post. Let's say we want to do get order.
Sorry.
Right?
Yeah.
So if I type get, you can see that, for example, I have this generic constraint, and I can say that it takes get order, and it will bind the incoming request to this get order, right? Using the .NET Core framework mechanism. And I could basically use the CTX, and from CTX I could do request services and grab my dispatcher and send this command and check if it's null or not, and maybe return 404 or not, and so on. But we can make better than this. And we can use additional method called use dispatcher endpoints. Always so many brackets.
Yep.
And dispatcher endpoints does pretty much the same what the use endpoints does, with one additional thing. It's integrated with our iCommand and iQuery dispatcher. So let's say I want to have this get, and for the get, I will say there is a get order query returning the order DTO. And here is my path, orders, and this is plain ASP.NET Core routing. And that's pretty much it. I have also two additional operations here, before I dispatch and after I dispatch, but I'm just saying, okay, let's do a get and return the data. If it's not found, it will be 404. And
so to make it clear, just to make it clear, so this line will underneath, this will expect the get order from as an input. So this will bind the order ID, which is in this route, put this into our query. And then underneath this will inject the iQuery dispatcher, dispatch the query, get the result, and which in this case is order DTO, and return this to the user, right?
Yeah, exactly. So if you look into internals, that's basically it. It's just binding this query root data, looking for the dispatcher, sending the query, checking if it's null, returning 404 if it's null, and so on and so on.
Oh, now I can see that we can refactor the is null, because now in C#8 we have this kind of buckets for.
We will, for sure. And another one, create order. And with create order, I can do the same. Let's say I want to send request to my orders, because I'm REST API guy, and when I post the collection, I expect that it will create a resource for me. And I could leave it like this, but let's assume that I want to return 201 with the location header. So here is my before and after dispatch. So after dispatch means that your command has been successfully processed, and let's return something meaningful from the server. So here I will have my command in the context, and command is of course our create order. This is our data, and context is the HTTP context. So I want to do the following: response, and I could just do write async or write JSON, or I could do status code, but I can also type created. And here I can pass my location header. Let's make it an actual endpoint, being orders, comment, or order ID. Okay, and let's see if it works. Let me restart it.
It has to work.
Yeah, it will work.
Otherwise, we would not record this.
Okay, so let's do a post. Just keep in mind that it's no longer API. I removed the API part, so it's just orders. Here is my location header.
Yeah.
And here is my get. Everything works. So keep in mind that you can use controllers as well. You can use this approach. You can use router with controllers, but you can also get rid of controllers at all. You could even get rid of routing and just use plain ASP.NET Core middleware. And if you are building very high performant APIs, really getting rid of controllers or even routing can give you nice benefit, like 20 or 30% of improved RPS performance. So just keep that in mind.
Yeah. Or switch to gRPC.
Oh yeah. Yeah, and also, for example, we think that if you open this small microservices or small web API and all of the endpoints are defined in a single file, well, it's just clear. So when a new guy comes to the team and he says, oh, here is the API, and I can just browse through this file and see what's going on. And then we can, move these comments and queries into separate layers and deal with business logic in different places. So our web API can become even a single file, program. Nothing else.
Yeah, because that's if you do your microservices, and you do your job well when it comes to architecture, then you should probably do not keep your business logic in the controller. So basically what all you're doing is creating a routing using the attributes, the MVC attributes, and forwarding this to some additional, so some business layers. So pretty much all methods looks the same. So it makes no sense. It's pretty predictable. In this approach, the only thing you need to care about is the name of the particular path, and the other thing is pretty straightforward. So
yeah,
we believe that this is a better approach.
Yeah, but it's really up to you. So just a different way. All right, let's go further with the stuff. Now, as we said, we have this pricing service that under this order ID pricing returns this pricing data, right? So we can assume that there will be some business logic executed, and we'll calculate the order price based on the customer and the discounts and so on. So what we want to do now is, if we get back to the command handler, what we want to do is we want to ask the pricing service for the data, right? And well, with ASP.NET Core, we can do something like HTTP client factory. We can inject the factory, get HTTP client here, and send a request and so on. But let us show you a little bit different approach. So what we want to do is we have HTTP client interface abstraction, and we want to use it in order to send the request to the service, and we'll show you like what are the potential issues with sending requests using hard-coded URLs.
Yeah, so, and believe it or not, HTTP client does not come from the ASP.NET Core. This is actually, or .NET Core itself. Yeah, this they did not create an interface, so we stole it.
That's funny, actually. Okay, all right. So let's do the actual abstraction, and here is the new directory. I called it services, and let's make a new interface. I'll name it iPricing Service Client, and it will be responsible for sending a simple request. Let's name it get async. For the order ID. All right. Pricing DTO is of course defined within our orders. We are not sharing any packages at all. We just have all of the DTOs or the models defined in the separate microservices. Yeah. And let's make an implementation of the service. So public, move to another class, to another file, sorry. All right. Now let me inject the iHTTP client. And before we go further, let me show you the app settings. Here you can see you have this HTTP client section represented by HTTP client options. We'll get to this type later on. Here we are using some retries with the poly library, and we also have this dictionary where the key is an arbitrary name of the service and the value is the URL. So for now it's hard-coded, and let's see if it works with the hard-coded URL. So let's get back to the client. We can inject these options. And we can grab the URL simply by taking it from the dictionary. So I'm looking for the pricing key, and of course in that scenario I will have this localhost 5003 for this pricing key. Read only. All right. So our get will be just a one-liner. Client get async, and it will should return the pricing DTO, and we can see that our pricing service has this endpoint here. And let me just do it like this: URL/endpoint. Okay.
Yeah.
That's it. Now let's get back to our handler and inject our abstraction. So we can do something like iPricing Service Client. And before we create
only
another
abstraction we have here.
Sorry?
Actually.
Yeah.
I mean the only abstraction.
The only proper abstraction that we have. That's true. And let's do pricing equals pricing service client get async for the order ID. And of course, if it was null, then we can throw an exception. And let's just pass the total amount here, like this.
Yep.
Maybe we can do something like if pricing is null, then let's throw new, whatever, operation exception, pricing is now. Okay. Otherwise, we just go further with the order. And before we restart the app, let's get back to the program, and we need to do
registration.
add HP client. For now, that's the only thing that we need to invoke, the only method. It will register our HTTP client and other abstractions. All right, so let's see if it works. .NET Run again.
I believe that you didn't register the client itself.
Ah, that's true. Yeah, we need to register the client itself. So somewhere before we add the Convey package, we can do just add transient using .NET Core IOC container. And for iPricing service client, let's register the pricing service client.
Yeah. Whoa.
Yeah.
Avoided the exception.
There will be no exceptions in this episode.
Yeah, that's the goal.
Hopefully. All right. Let's do a post. All right, post succeeded. Let's do a get. And succeeded 2050. And we can see that here in the logs, there is get from this pricing service. And in the pricing service logs, we can also see that there was the get request to the service. So everything worked as expected. But
and the value is different. So
and the value is different, 2050, right? So it succeeded. But the issue is that, well, right now we have the hard-coded URLs, right? So if we take a look here, this is hard-coded. And what if there are multiple instances of the service, right? So we'll not get deeply into this topic, how to deal with load balancing here or how to do service registry. We'll just show you that, well, you can actually use the tool that will, I would say, resolve this issue for you, right? So if you've ever heard of this term service registry, we're actually looking for a solution in which instead of sending the request directly to some hard-coded microservice, having this hard-coded URL, we'll ask an external registry, hey, here is the service name. For example, using some key or DNS, give me the instances of the service so I can, send the request to this service directly.
Yeah, and of course, to make this whole mechanism work, each service on startup needs to register itself to the registry, right? So in this case, the pricing service during the startup will send the post request to. In this case, we'll use the console service discovery, and we'll say something like, okay, so under this, I'm the pricing service, this is my key, and this is the data needed for clients to reach me out, right?
Exactly.
So if we go to we can click on the pricing service or something to show this.
So here is the console running through the Docker on our local host. You can see there are the services, one instances of delivers and pricing service. We have the address of a service, the name, the group, the unique ID, and the health check, because console can also ping the services and remove them if they are no longer responsive. So how we can use the console here? Well, at first, let's change our console tab from enabled to false to true. Here is the URL of the console, the name of our service, so we'll be registering our instances under order service key. There is the address to our instance, and also some health checking stuff. Like, let's say, let the console ping me under the /ping endpoint, or maybe under home endpoint or anything else. And we'll also change this HTTP client type to use console. And in that case, we'll not be using anymore these localhost hard-coded URLs. We'll stick to the name of the service. So we'll be asking pricing service as it's registered in the console itself. So
in case that we'll have multiple instances of the same service, each of them would register under the same key. So in this case, there'll be the pricing service or something else, right? Mm-hmm. But we would have multiple registries from which we could choose the one that we want to call.
Exactly.
Yeah.
All right.
So we have this.
Yeah. This is the definition in the app settings. And let's get back to the program. And here, we just need to say add console, okay? And nothing else. So add console under the hood, we'll use our Convey console package. This is something that we've just changed, because in the past we used the console.library that is no longer maintained. So we need to create our own wrapper, which is basically a simple HTTP REST API calls, and it will register the console during the startup. And you will see the difference. So maybe I'll run it in the debug mode here. So if we go back here to our command handler, and let me open also this one, and I'll put a breakpoint here.
You will see why we're actually using the abstraction of the IHTTP client.
Exactly. This is why we have this interface in the first place. So let me stop it here and let me start it in a debug mode.
Shouldn't we also include the use console?
It's no longer valid.
Yeah, right after. Okay. Switching.
Yeah. So here is our order service. It registers itself to the console. You can also see in the logs here that it's registering. So registering a service with this ID in console.
Yeah.
It's been registered in console. And if I stop the app, it will register itself directly. But let's say someone kills my application, there was no graceful shutdown, it couldn't register itself, remove from the console on its own. So this is why we have health checks in place, because console will remove these dead services on its own behalf. All right, now let's do the post request again. We should hit a breakpoint, and if I do F5, as you can see, we are using now console HTTP client type, right?
Yes.
So this is why you have this abstraction here, because using the simple switch case, we can use different implementations. And in this case, we're using console HTTP client with console message handler.
Yeah, F5, and the URL now is the DNS, right?
Yeah.
So the DNS.
Let's open the console logs again. As you can see here, we try to do the GET request for the pricing service, right? No localhost pricing. Then we ask console, the console API, hey, return to me the services with this name. So if I open this API in the browser here, let me show you that. Yeah, here is the console API. So here is the single instance of our pricing service. And now let's do F5, and everything works as expected. Eventually, we hit the URL of our microservice, since the console returned the list of available instances of the pricing service back to us. So in total, there were like 2 requests. One to console to grab the services, and the other one, once we have the services list, there was another request to the actual service.
Yeah, and that was the so-called client-side
load balancing, right?
The service discovery.
Service discovery,
exactly.
Exactly.
So basically, the client decided which, in case of having multiple registrations under the same key, the client is responsible for choosing the one that you actually want to reach. And of course, we could and we will switch to the server-side service discovery when we have additional load balancing. And this is no longer the client's responsibility for dealing with the multiple instances of the same service.
Exactly. So what we can do better here? Well, we can stick to console, but we can also put the load balancer on top of it. And in that case, we'll use the Fabio, which comes from the eBay. It's an open source project created by an eBay. It's maintained, and it's built on top of the console. And the Fabio is already running on our localhost 9998. Here is this dynamic routing table, and the way it's building those services, the way it's adding the services to the routing table is by using the console tags. So you can see here that our services have those special tags: URL, prefix, name of the service, and then strip. And this is why the Fabio is able to build the routing table. Okay.
Yeah.
Now let's get back to our code, and in app settings JSON, we can change this Fabio enable to true. Here is the load balancer URL, not the Fabio UI, just the Fabio load balancer URL. So where the load balancer actually lives. Name of our service, which has to be the same as our console service key. And we'll just switch here from the console to the Fabio client. And also we'll add the Fabio integration as well. And let's start the app one more time. And guess what? We'll do the post request.
Yeah, one more time.
Yeah, I think it will be at least 2 more times.
Yeah, if someone could count how many times we actually hit the post,
I think it's 10
that would be
times.
cool. Post is
Okay,
we'll
so
pay
F5,
some reward.
and now we're using FabHP client type, right? So another
Yeah.
implementation. And F5, and if you take a look at the logs, let's see. Console, now we are hitting the pricing service client, and within our Fabio HTTP message handler, we are changing this key to localhost 99/pricing service and the actual endpoint. And let's just finish it, and I can open it in the browser. And yeah, here is the traffic going through the load balancer to the particular service instance, and it's now up to Fabio which service to choose. And it's no longer up to us, to the client side load balancing and service covering. If you want to use something more sophisticated, you could, for example, look for the traffic. And also traffic works with console. So you can do something like traffic console, and you can integrate with traffic if you want something else. Because keep in mind that different load balancers have different mechanisms. It can be simple round robin, randomized round robin, or a more sophisticated scenario which takes into consideration the actual request times, perform some calculations, calculates the average of responses, and so on. So whatever you want. And you can also skip this service coverage part and just stick to the Docker Swarm, or Kubernetes, and the simple round robin and DNS mechanism, and you'll be fine as well. So it's really up to you.
That's actually pretty important stuff that you just said. So this is not important in case of having the Docker network and so forth, because we'll stick to the Docker DNS.
Yeah, but once you think about some topics like service meshes and so on, this is where console might come in handy with their console connect, or you can use Istio, or other stuff. But this is not for today's topic. Just keep in mind that you can either use the service service registry tools, or you can just leave it as this and stick to maybe Docker and Docker, or Docker Compose and Docker Swarm, and you'll be fine.
Yeah.
All right. So far we've had the synchronous communication. Yeah. HTTP. We could also do the gRPC, but we don't want to talk about gRPC in this episode. So let's switch to the actual asynchronous integration, which is great because there is no temporal coupling anymore. If service A wants to send something to service B, it can be sent through the so-called message broker. And even if the service B is down, it will grab this message from the broker once it's available again, and there is no coupling at all between services. But there is asynchronicity, there is mutual consistency, and some other funny things that we will not talk about.
Basically the async stuff is better once you actually process something. You want to inform other services that something happened inside your service. So you're basically publishing so-called the integration event, and whoever wants to subscribe to this will subscribe and perform some other action. So this could be sending an email because we created an order. So sending an email to client with the confirmation or whatever you want. Yeah. So for our case, we'll use the RabbitMQ. We could maybe in the future we'll think about other brokers. But Rabbit seems like the easiest one, I would say, and it's
one of the most popular ones.
For most projects, it's fine.
Yeah. And it's different than Kafka. Kafka is more for just events and streaming, which is where it really shines. And RabbitMQ is just a message broker. Yeah. You can send events through them. You can send comments through the RabbitMQ, and it's very popular stuff. So we're just using it here, but it can be anything else as well. And for the Rabbit, we actually have two packages: the raw Rabbit, which is the abstraction over the raw Rabbit library, and RabbitMQ, which is the abstraction over the native RabbitMQ library for .NET. So we are
one more thing related to Convey. If you would like to create your own integration with other brokers, we also have the message broker package, which provides the abstractions. So just follow the abstractions we have, and maybe you would like to implement your own publishers for other technologies.
Yeah, and this is something that we'll probably factor in the future, and we'll put these parameters into some structures and classes. So. But for now, it does the job, gets the job done. All right, so we are adding the RabbitMQ integration. Just add RabbitMQ, and we also need to say use RabbitMQ. I will
also show the app settings.
Yeah, I'll just put it here at the very bottom.
Yeah, it will be the best.
All right, and yeah, in the app settings, we have this big section, RabbitMQ, name of the connection, retries if you are doing retrying processing, let's say commands or events in memory, some conventions, whether we should log some internal stuff. The message processor, in that case, should be actually distributed. So this is about dealing with processing only the unique messages based on their IDs, and the connection stuff. So host name, local host in that case, ports, virtual host, endpoint, credentials, timeouts, and just typical stuff for the RabbitMQ. Okay, so maybe let's go to the Rabbit, I think. And right, so we should just restart the app and see what happens. .NET
Yeah,
run.
but should also publish something, right?
Yeah, just in a sec. Let's see if we actually have the connection with Rabbit. So if we open this one, guest, connections, there should be our connection. Yeah, here is the order service. Okay?
Yep.
Cool. Let me stop it. And yeah, let's publish something. So within our create order handler, we can inject the iBus publisher abstraction, and we can publish the following. So after we created the actual order and stored in the database, we want to publish this information to the rest of the system. So you can publish an event, and here we already have defined this event named order created. And again,
so the same story with the command. We have the interface, which is nothing more than marker for generic constraints. Yeah.
Same stuff, immutable event.
Immutable.
All right, new order created with our comment order ID. Okay. And we also have this event handler. So what should happen now is that once our processing is done, we should publish this order created event, and the deliver service, which also uses the RabbitMQ, you can see here, it subscribes to this order created event. And this order created event will be handled by this order created event handler. So the same stuff as with the command handlers, we also have the events. And also this single operation called handle async for this particular message type. All right, so let's see if it works.
Underneath the subscribe works pretty much the same way like the web API. So basically it uses the dispatcher. We have also some poly involved in the whole process of dealing with this message and so forth. Yeah.
So here it is. Here we publish the message to the RabbitMQ with some message ID, collation ID, and here is our service that received this message with this ID at this timestamp with some additional headers from this exchange with this routing key and so on. It handled the message and also published another message with the key delivery started to this exchange. So just the RabbitMQ stuff. And let's get back to our writer. And if I, for example, stop it, I can also say I want to subscribe to either comment type or event type. So I want to subscribe to the event named delivery started, which is defined here under our events external delivery started, and it's coming from the exchange deliveries. And we have the handler that does pretty much nothing, just logs some information. And in order to make it work, I need to add one more thing, add event handlers and add the event dispatcher. Actually, I don't need the event dispatcher, just event handlers. All right, so let's see. Let's do a post. Oh, I think
we have the
Oh, I know what happened. I didn't add the Redis. Yeah, sorry. I forgot to add the Redis integration, so I will just disable it for now.
Went so far.
Yeah, but let me try with actually adding Redis. It should work. Sorry, this one.
Yep. So the message processor for processing the messages within our broker.
Yeah, now it works.
Let's
Yeah.
see. Okay.
So published message, the .NET run here, and we have the published delivery started event to these action deliveries, and we subscribe to this message here, and we process it in our own message handler. So everything has been done asynchronously, just sent to the message broker. As you can see here, there were the picks coming from the messages received, message handled, and asynchronous integration simply done with RabbitMQ. All right. Another thing, because as you might notice, even though there are just 3 very dummy microservices, there is actually quite some stuff going on. And how we can find out what's actually happening with all this stuff? Well, of course, you can do logging. And here we have our logger section where you can just log to the console, look to the file, log to the sec. You can do metrics, you can do monitoring, but we'll not get into this Grafana or Prometheus stuff today because it's also available in our Convey. We'll talk about the open tracing, right?
Yeah, I would like to basically what would be cool would be the visualizing somehow the data flow in our system, right? So we would like to see how the data goes from one service to another, and what's the dependencies between our microservices. And this is when the not the open tracing, but the distributed tracing in general comes to play. And for our implementation, we chose to use the open tracing. So as you see, vendor natural API, and they have instrumentation for the creating the spans, so-called spans. So basically, the unit that is used in a distributed tracing, and yeah, this is nothing more than an instrumentation for our system, and we'll also use Jaeger, which is the I would say this comes from the Uber, and this will be responsible for taking the spans created by our application outside and storing them somewhere in some data store, and with then there will be some querying involved, and as a result we should see the visualization of our data flow within our microservices. So this is basically what we would like to do now. So yeah, we have this Jaeger stuff here.
Let's make it enabled to be true. Here's the Jaeger URL, port, and so on. And
by default this is a UDP because we don't want to
it has to be fast. We don't care if some packages are lost during the way. And before we go further, as you can see here, we have this open tracing package. So it's an official open tracing NuGet package, and we can just add it somewhere here, open tracing. And we also need to add the Jaeger integration coming from the Convey, actually, like this. And we need to use the Jaeger middleware, so we'll be able to actually talk to Jaeger and send to the Jaeger our tracing.
Yep.
And let's see, we should already have some results. So let's just restart the apps.
So nothing more is required, right?
Yeah, just add open tracing, add Jaeger, and use Jaeger. And let's do this pause request again.
And of course, the same registration was in 2 other microservices. So to make it clear.
Yeah, the services use the same Jaeger stuff here as well. And if I open the browser and the Jaeger on my localhost, sorry, not the Rabbit, just the Jaeger, you can see here that there are my services registered into the Jaeger. I can do this find traces. And yeah, here are my traces coming through, they actually cut through these 2 services. So I can click here, and here are the traces. So there was a post as this big span. There was this get request underneath, and this get request asked the different service, pricing service case, to actually, calculate the order price. And we can also visualize it as a graph. So post and get to the pricing service, and you can also see in the dependencies that here I actually in total clicked this 3 times, so we have 3 get requests from order to pricing. And if there were more services, there will be actually more circles.
Yeah, more complex.
More complex graph. But
Yeah, so this is great tool to because this I would say this is some combination of so the visualization is one thing, but this also each span can have multiple logs inside, so we can create our custom spans and log whatever we want to this. Of course, open tracing gives us some basic spans for ASP.NET Core applications with their own logging, but this is also a great tool for spotting some bottlenecks. So we could see that, for instance, I don't know, some SQL connection takes way too much long time, and maybe we should check the logs of the SQL database. Maybe there's some issue. But besides that, we can simply see what's going on in the distributed system, how each of them communicate with each other. But it's worth mentioning that by default, Jaeger supports only HTTP calls, right?
exactly.
So if you as you have seen, Piotr clicked the post request, but we only saw the two services involved. So there was no other spans created by publishing the events for the deliveries service and back to the orders service.
Yeah, so we have the tracing for our getAsync, which is like for free, it's simply by using the open tracing library, and it's it does this tracing for the HTTP communication. But there is no tracing for async communication, which it is natural, right? But we would like to have it because we are publishing this event here, and this event is handled by this service, and we like to see in Jaeger that actually this service was also involved in this flow. So we can easily do it. So let's get back into the program CS, and under RabbitMQ we can do this plugins, and we can invoke add the Jaeger RabbitMQ plugin, which is nothing really else than just a decorator on top of the RabbitMQ. So what will happen now? If we get back to our handler, we can inject the iTracer, which comes from the open tracing library. So it's tracer.
Yeah.
And from the tracer, we can get the span context. So tracer active span context to string, like this. And we can pass the span context with our messages. So here is the optional parameter called span context. And under the hood, the span context is serialized as the RabbitMQ header. So if we look at the settings, for example, in RabbitMQ, you can find here that we have the span context header, and we can also use our message context header if you want to pass along an additional object with some metadata or anything else that you want to do. But for this sample, we'll just use this span context header. So right now, the RabbitMQ, once deserialized, the actual service using this RabbitMQ plugin, for example, this one, which also uses the plugin, should deserialize this header and use this tracer to actually build the span based on the span received from the through the message broker. So let's see
and
next.
keep in mind that the actual implementation of the one that actually created Piotr created in a minute. This whole iTracer thing should be kept somewhere else, of course. We don't have an API gateway, and this is natural place for this. So on the system entrance, we would like to create this span for the coming HTTP request, and then propagate this within our microservices.
Yeah.
So basically,
and this is a sample plugin.
Implementation. So.
Just grab the header from the incoming message if it's there, encode the span context, build the scope, and just maybe add some tags here, and so on, right?
Yeah.
And just invoke our handler internally. So just the decorator pattern, nothing else. And let's get back to the code and let's run it one last time, I think.
Yeah. Hopefully this will work.
Yeah, it will work, I'm sure. Post. Okay, let's do a few more. and there are no errors, which is a good sign. Cool. So let's get back to our Jaeger. Find traces. And here is.
Yeah.
Here is the trace, including 3 different services, right? So orders, post, delivery service. So here is our asynchronous message. And in the graph, we can also see that there was a post, there was a get to the pricing, there was the actual deliveries, receiving, processing, order created, and we also received eventually the delivery started from the delivery service. So we can see that right now, oh, maybe there are too many, not like actual dependencies, but too many messages being, passed along between different services. Maybe our service shouldn't consume this event, or maybe this service shouldn't be, we shouldn't send the data to this service, and so on and so on. So this is really nice tool, really nice idea how to trace your request, whether they are synchronous or asynchronous. You can see, you can easily create your own plugins using Tracer and, pass along your span context using headers or some other techniques. And yeah, that's pretty much it. I think we have, of course, more integrations. Like you can do integration with Grafana, you can do integration with Sec, you can do integration with, here's the logger,
Prometheus,
Prometheus for monitoring, alerting. You can do integration with Vault, and so on and so on. But this is something that we also talk about in the distributed.NET Core course that, of course, you can find and watch here. So that's pretty much it about Convey. Feel free to test the code, fork the code, send issues, send pull requests.
Hopefully you'll like it. If you'll have any suggestions, some issues, just use the GitHub issues. That will be the easiest way to communicate to us. Or, I don't know, maybe some Twitter or something.
Yeah. We have a Gitter channel and the forums for our distributed.NET Core course and the DShop, so you can just go to our website. Here, and
we have the Gitter.
There's the Gitter, so you can open the Gitter, join the channel, or just send us a message or send an issue, anything else. We've been also working recently on the Outbox pattern. We are also trying to integrate with Console Connect or Envoy or some other proxies and service mesh stuff. So more things, more good things to come.
Coming.
Yeah. So thank you for watching. And if you have any questions, just post a comment or send us a message.
Yeah. I must say, before we actually finish this video, that I think that was pretty cool. 1 hour long video, and we created pretty cool microservices. So you can see that this is the creating microservices does not necessarily have to be painful, because we've already done it, and we had a lot of pain there.
Yeah.
So you don't have to.
Just focus on the business logic, not on the infrastructure. Just use this extension methods, plug into your infrastructure as seamless as possible, and just focus on writing the performant code and
the actual
application. Yeah, the actual code, not integration, not being a DevOps, and just spending a month or half a year trying to integrate with 20 different infrastructural tools. So that's the idea behind the Convey as well. So that's it. Thank you for watching, and see you soon.
Yeah, see ya.